Hi everyone, welcome to new class. Today's class is about edge triggered flip flops. It is also called dynamic triggering. That is, triggering is also called dynamic triggering. The flip flops using the clock signal are called the clocked flip flops. That is, clock signal is like this. So this is a clock signal, and the clock signal is distributed to all parts of the system, and most of the system outputs can change state only when the clock makes a transition. And clocked flip-flops may be positive edge triggered or negative edge triggered. So this is positive edge triggered flip-flop, and this is if the clock is like this is negative edge triggered clock. And positive edge triggered flip flops are those in which state transitions take place only at the positive going. That is, positive going means this is 0 to 1 or low to high state. So here the positive going edge of the clock pulse, the state transition take place, and in the negative edge triggered flip flops, the state transition take place only at the negative going, that is 1 to 0 edge of the clock signal. And positive edge triggering is indicated by a triangle at the clock terminal. So this is clock terminal. So positive edge triggering is indicated by a triangle at the clock terminal of the flip-flop, and negative edge triggering is indicated by a triangle with a bubble at the clock terminal of the flip-flop. Thus, edge-triggered flip-flops are sensitive to their inputs only at the transition of the clock. And there are three basic types of edge-triggered flip-flops: SR, D, and JK flip-flops. The edge-triggered SR flip-flop. So this is the logic symbol and truth table for the positive edge-triggered SR flip-flop. And the S and R inputs of the SR flip-flops are called the synchronous control inputs, because data on these inputs affect the flip-flops output only on the triggering, that is positive going edge of the clock pulse. And without a clock pulse, the S and R inputs cannot affect the output. And when S is high and R is low, the Q output goes high on the positive going edge of the clock pulse, and hence the flip-flop is set. When S is low and R is high, the Q output goes low on the positive going edge of the clock pulse, and the flip-flop is said to be in reset state. When both S and R are low, the output does not change from its prior state. And when both S and R are high, then the output is in invalid state. And this is the negative edge triggered SR flip-flop. This is the logic symbol and this is the truth table. And here also, when both the inputs are 0, then the output is no change. That is on the negative going clock pulse. And here when S is 0 and R is high, on the negative edge of the clock pulse, then the flip-flop is in reset state. And when S is high and R is low, then set state. And when both S and R are high, then invalid state. Let us study about the timing diagrams. For the waveforms applied to the positive edge triggered SR flip-flop, sketch the output waveforms. Initially set state. So this is the clock pulse given and these are the inputs, that is S and R given to the flip-flop. So we have to draw the output waveforms Q and Q bar. So this is a positive edge triggered flip-flop. So the output transitions take place at the positive edge of the clock pulse. And initially it is set state. So Q is equal to 1. Q is equal to 1 up to the positive edge of the clock pulse. So when the positive edge occurs, that is at this state, S is 0 and R is 0. That means no change to the output. So Q is high again and Q bar is 0 up to the next clock positive edge trigger, edge of the clock pulse. That is up to next positive edge of the clock pulse. It is high. So up to this point it is high, that is Q is high and Q bar is low. So next clock pulse is this one. So in the positive edge S is 0 and R is 1. That means Q will become 0. That is it will become 0 here and Q bar is high at this point, that is 1. And it will continue up to next positive edge of the clock pulse. So next positive edge is this one. So up to this point it is 0 and this is high up to this point. And at this point, that is in the third clock pulse, S is high and R is low. That means Q is high. Q is high and Q bar is low at the edge of third clock pulse. And it will continue up to next edge of the clock pulse. So up to this point it will be high and this will be low. And at the fourth clock pulse S is again high and R is low. That means Q is again high. So it will continue up to the next clock pulse. So up to this point it will be high and this is 0. Q bar is 0. So at this clock pulse, that is at the positive edge of fifth clock pulse, S is 0 and R is 1. That means Q is equal to 0 at this point and Q bar is 1, and it will continue up to the next positive edge of the clock pulse. And at this point, that is at the 6th clock pulse, S is 1 and R is 0. That means Q becomes high. Q bar becomes 0. So this is the waveforms for this output waveforms for the given input waveforms. Next is the edge triggered D flip-flop. The edge triggered D flip-flop has only one input terminal, and the D flip-flop may be obtained from an SR flip-flop by just putting one inverter between S and R terminals. And this is the logic symbol and truth table for the positive edge triggered D flip-flop. And here, if D is 0, then Q is equal to 0, that is reset state. And if D is 1, then Q is equal to 1, that is set state. And the negative edge triggered flip-flop operates in the same way as positive edge triggered D flip-flop, except that the change of state take place at the negative going edge of the clock pulse. So this is the logic symbol and truth table for the negative edge triggered D flip-flop. Let us study the timing diagram for the D flip-flop. So for the waveforms shown applied to the D flip-flop, draw the output waveform. So this is the clock pulse given, and this is the D input given, and this is negative edge triggered flip-flop. So the state transition take place at the negative edge of the clock pulse. So assume initially Q is set. So Q is high up to the negative edge of the clock pulse. So at the negative edge of the clock pulse, D is 0. When D is 0, then Q becomes 0. So at this point, Q becomes 0, and it will continue up to next negative edge of the clock pulse. So at this point, D is 1. So when D is 1, then Q becomes 1. So at this point, Q is 1, and it will continue up to next negative edge. That is at this point, Q is 1. And at this negative edge of the third clock pulse, D is 0. So Q becomes 0 at this point, and it will continue up to the next negative edge of the clock pulse. So up to this point, Q is 0, and at this point, D is 1. So Q will become 1 at this point. So this is the output waveform corresponding to this input. Next is the edge triggered JK flip-flop. The JK flip-flop is very versatile and also the most widely used. And the functioning of the JK flip-flop is identical to that of the SR flip-flop, except that it has no invalid state like that of the SR flip-flop. And this is the logic symbol and truth table for the positive edge triggered JK flip-flop. So here, when both the inputs are 0, then no change to the output. When J is 0 and K is 1, then the output is reset, that is Q is equal to 0. When J is 1 and K is 0, then Q is 1, that is set state. And when J and K both the inputs are 1, then Q is T, that means toggle. Toggle means the output goes to the opposite state of the previous output. That is, if the previous output was 0, then after applying 1 1 to the flip-flop, then output becomes 1. And if Q is 1 in the previous state, after applying 1 1, then it will become 0. That is toggle. And all this happens for the positive going edge of the clock pulse. And next is negative edge triggered JK flip-flop. And here also, when J and K are 0, then no change to the output for the negative going edge of the clock pulse. And when J and K are 0 and 1, then output is reset. When 1 0, set state. And when both the inputs are 1, then toggle state, that is opposite state. Let us study the timing diagrams for the JK flip-flop. So the waveforms shown are applied to the edge triggered JK flip-flop. Draw the output waveform. So these are the input waveforms given. So this is the clock pulse given. So here this is a negative edge triggered JK flip-flop. So, and assume Q is set in the previous state. So Q is 1. Q is 1 in the previous state, and it will continue up to the negative edge, first negative edge of the clock pulse. So up to this point Q is high. So at the negative going edge of the clock pulse, J is 1 and K is 0. That means Q is 1 at this point, and it will continue up to next negative going edge of the clock pulse. So up to this point it will be 1. And at this point J is 0 and K is 1. That means Q is 0. Set, that is reset condition at this point. And it will continue up to next negative edge of the clock pulse. So up to this point it is 0. And at this point J is 1 and K is 1 again. So 1 1 means toggle state. Toggle state means it will be in the opposite state of the previous output. That is, here it is 0. So here it will be high. At this point it will be high. So 1 1 means toggle state. That is, if the output was 0, then it will become 1, and if it is 1, then it will become 0. And it will continue up to next negative edge of the clock pulse. And at this point J is 0 and K is 1. That means Q is 0. And it will continue up to the next negative edge of the clock pulse. So up to this point it is 0. And at this point J is 0 and K is 1. That means in the reset state. So Q is again 0 at this point. So this is about the timing diagram of the JK flip-flop. The edge triggered T flip-flop. A T flip-flop has a single control input labeled T for toggle. When T is high, the flip-flop toggles on every new clock pulse. When T is low, the flip-flop remains in whatever state it was before. And a T flip-flop can be made from JK flip-flop by just connecting J and K together and labeling the common connection as T. Thus, when T is equal to 1, we have J equal to 1 and K equal to 1. That means in toggle state. And when T equal to 0, that is J equal to 0 and K equal to 0. That is no change for the output. So this is the logic symbol and truth table for the positive edge triggered T flip-flop. Thank you for watching the class. If you like the classes, please like, share with your friends and subscribe my channel.